So I would first like to apologize for the quality of this video. I'm just starting this channel to go over some things in electronics that gave me some issues when I first got started and showcase like my basic projects. So I'm just going to use my phone to record this stuff and go over it step by step. The first thing that I want to look at is the low pass filter. I had a lot of trouble doing this stuff, so I'm going to give the mathematical description and then show you an example on my oscilloscope. So the transfer function of the expression, or like the whole point of this, can be seen by switching the components to the frequency domain and then going through a mathematical description. So I like to use the voltage divider law to help see this. As you can see, we switch the capacitor and the resistor into impedances right there. And then we can find the output voltage, which is the one that appears over the capacitor, with the voltage divider equation. You do some simplifications, you get this expression right here at the bottom. V0 equals, or approximately equals, Vs over 1RSC plus 1. You can then take the limit of that expression and see that as our frequency, or S, goes to infinity, or j omega, whatever you want to reference it as, the output voltage as a percentage of the input voltage is 0. So nothing appears over the output node. On the contrary, at the lowest frequency possible, S or j omega equals 0, you can see that we get all of Vs across the output node. So here's what that looks like on the oscilloscope. I have an input voltage and an output voltage. Our peak-to-peak voltage is 251 and our frequency is low. It is 200 hertz. The waveforms are almost identical. If we go to this measurement thing right here, we can see that the max voltage on one is the same as the max voltage on the other. Now, if we want to look at it from a high frequency perspective, we can go right over here and adjust the frequency to, I don't know, 50,000, okay? And we get one of them is 0, and one of them is this, the input sine wave that we put in.